In Chapter 6, we're going to be factoring polynomials. Now, everything has its opposite. The opposite of multiplication is division, the opposite of addition is subtraction, and the opposite of the distributive property is called factoring. So we've been doing a lot with distributing in the last chapter. Now we need to learn how to undo that, how to factor. And to start with, we need a couple definitions right here. So we're going to recall that the greatest common factor, GCF, for a list of integers is the largest common factor of those integers. For example, 24 and 30, the GCF is 6 because 6 is the largest number that will divide evenly into 24 and 30. Okay? For 27, 45, and 72, the GCF is 9. Now let's test that. How do I know that it's 9? Well, I know that 27 is 9 times 3. I know that 45 is 9 times 5. And I know that 72 is 9 times 8. Alright? So what I'm saying here is that 9 is in common. 9 goes in to all of these values. And it's the greatest common factor because the leftover pieces don't have anything in common. There's no number that goes into 3, 5, and 8. That is one way of proving that 9 is the greatest common factor. Okay, let's look again at 30 and 75. Okay, 30 is, I was going to say 2 times 10, but let's go with 5 times 6 instead, because I know that 10 and 2 don't go into 75. So 30 is 5 times 6. 75 is 5 times 15. Alright, now the 5 is in common, but that's not enough. It's not enough because there is a number that goes into both 6 and 15. That number is 3. So that tells me if I break my 6 down into 3 times 2, my 15 down into 3 times 5, they're also going to have the 3's in common. So the greatest common factor is 15. Alright, I could have gotten there faster if I would have said, okay, 30 is 15 times 2 and 75 is 15 times 5, and I would have been done. But I'm just trying to show you a way of breaking it down piece by piece to find the total sum, the total product of all of the factors that are in common is the greatest common factor. Okay? Alright, on to the next one. This one is the first one with variables. So when I'm doing a term with variables, I'm going to look at just the numbers first, then I'll go to the variable. So 9 and 15. Oh, I'm sorry, I skipped this one. My bad. This one was kind of hidden under here. Let's see. 12, 15, and 20. Alright. 3 goes into 12, 3 goes into 15, 3 doesn't go into 20, so 3 doesn't work. 2 goes into 12 and 20, but not into 15, so that doesn't work. Okay, so let's start breaking these down again. The easiest one to break down is 15. There's only one way to make a 15. There's a couple of ways to make 12, 2 and 6, 3 and 4, and so on. So I'm going to start with 15. There's only one way to make 15. 3 doesn't go into all of them. 5 does not go into the 12, so the greatest common factor is 1. 1 will go into anything, but there's no number larger than 1 that goes into all 3 of those numbers. So it's just 1. Okay? And now onto the ones with variables. If I'm looking at an expression with variables, do the numbers like normal? The greatest common factor of 9 and 15, the largest number that divides into those is 3. 3 goes into 9, 3 goes into 15, but no large number goes into both. And for my variable a, there's a single a here. There's a whole bunch of them here. So if I have the greatest common factor being 3a, that's enough a's for this one, and it's more than enough for this one. This one, I could have up to 5 a's, so just one right there is plenty. Okay? So I need... actually, it's always going to be the smallest power on that variable right there to make sure that I don't have too many for the lowest power and I have, extra room in the larger power. Okay? So in 8, x to the 7th, and 24, since 8 goes into 24, 8 is going to be the numeric part, and then x to the 5th is going to work out fine here because 5 covers this one, and I've got more than enough over here to deal with that 5. Okay. 6, 10, and 15. Okay, 6 is 2 and 3. 2 won't go into 15, 3 won't go into 10, so I'm just going to have 1. N to the smallest power is 4th. Or I don't really need to write the 1 in this case because I can just say n to the 4th. Okay, so n to the 4th would be the GCF on that one. And our last one here, 12, 18, and 15. 3 goes into all of those. Nothing more than 3. I know that because 3 times 5 is 15, and 5 won't go into these. So it's going to be 3, w to the first, the lowest power of w, and z to the second. That's the smallest z value that we see. So the combination of those is 3wz squared. Alright, so just a summary right here of what we've done. When I'm finding the GCF of a list of monomials, how does this work? So for the coefficients, I want to find the largest number that divides evenly in to all of the numbers. Alright, and when I'm looking at the variables, it's always going to be the smallest exponent. By choosing the smallest exponent, that's going to be the largest variable that divides into all of the variable components. Alright, let's go on to the next. Alright, so on this next page, we're going to use what we just learned about GCFs to start factoring these expressions here. So in example 1, I'm looking at 5x and 10, and I can say off to the side right here that the GCF, the greatest common factor, is 5. I know 5 goes into both 5 and 10, and I don't get to write any x's because the lowest number of x's is not having any x's at all. Right? There's 1 there, but 0 here, so just 5. Okay, so the GCF is 5. My first step is to find the GCF, write it down, and then open parentheses to write down what would be left if I took that out. Now I'm doing the opposite of distributing, and remember if we have a distributive property, when I do distributing, I multiply that in. So when I am factoring, instead of multiplying something in, I'm going to be dividing it back out. So let's look right here at 5x divided by 5 would just be x, 1x, and 10 divided by 5 would be 2. Right? Now we can check ourselves because if we multiply back in using the distributive property, we're going to get right back to the original. 5x plus 10. So this is my factored answer. I've factored out that GCF. Let's look at the next one. 125 and 20. I can divide them both by 5. That's as far as I can go because this is 5 times 4, and 4 is an even number. It's 2 times 2, but this is odd. The 2's won't go in, so I know that 5 is the biggest number. I started my parenthesis a little bit early, though, because they both have an x. So the lowest number of x's they both have is a single x, so it's 5x. That's the GCF. Now let's take that out. 125 divided by 5 is 25. X squared divided by x, so if you have 2 and you're taking 1 away, there would be 1 left. Minus, it's going to be minus because I've got a negative 20 divided by a positive 5 is going to be a negative 4, so my minus 4 right there. And you've taken the x out, so there aren't any x left. So again, that's factored. Okay, next. 15 and 12 can both be divided by 3. W cubed and w squared, so the smallest value is w squared. Let's take that out. When I divide by 3, I get 5. Remove 2w, there would be 1 left. Plus 12 divided by 3 is 4. Both w's have been taken out. So I close my parenthesis, that's finished. If you check it, 3 times 5 is 15, w times w squared is w cubed, 3 times 4 is 12, w squared. So it checks. Alright, and the next one is a trinomial, no problem. We can do 100, 50, and 100 can all be divided by 50. And y to the 5th, y cubed, y squared, they all have at least y squared. 100 divided by 50 is 2. Took out 2 of them. There were 5 of them, so there's going to be y cubed left. Minus 50 divided by 50 is 1. I'm not going to write the 1 because I can just leave it as a y, since y cubed divided by y squared is y. So 1y or y is simpler. I'm just going to leave it like that. And 100 divided by 50 is 2. Y squared divided by y squared, all the y's have been removed. Now notice that my symbols are just the same. This is a 100 divided by positive 50 is a positive 2. If it's a negative divided by a positive, it's still negative. Positive divided by positive, it's still positive. Okay? So the symbols are going to be the same as they were originally unless you're factoring a negative number out, which is what we're going to look at next. Now, if the first term, the leading coefficient, like this one right here, if the leading coefficient is negative, we're going to factor out the negative. Okay, factor out the negative if the leading coefficient is negative. So that's to say, looking at these two numbers, 5 and 45, the GCF is 5, but I'm going to take out a negative 5 instead of just a regular 5 because it was the first term, the leading term, that was the negative. Now we're also going to take out x squared because that's the smallest power of x. Okay, negative 5 divided by negative 5 is positive 1. Don't need to write the 1 because there will be some x's left, 1x left. 45 divided by negative 5 is negative 9, so your sign does switch there because you took a negative out. And no x's left. Okay, if you multiply back in, negative 5x squared times x will be negative 5x cubed. Negative 5 times negative 9 is positive 45 in our x squared. Alright, in part B, the first term is negative, so we're factoring out a negative, and 4 and 6 have a 2 that you can divide them both by, and a they each have, and a b they each have. So I'm going to take out negative 2ab. I'm going to take out the negative 2. Negative 4 divided by negative 2 is positive 2. Take out 1a, so there would be 2 left. Take out 1b, so there would be a single b left. Then 6 divided by negative 2 is negative 3. You've taken the a and the b out, so last term is just negative 3. Alright. Our next objective is to be factoring by grouping. So looking at the first example right here, if I have ax plus 5 and I want to factor that, there's an x in common. Both of them have an x, so I'm going to take that out. And what would be left would be a plus 5. Right? That makes some sense. I mean, both of these had the x. If I take the x out, ax divided by x is a, and 5x divided by x is 5. Or when I multiply back through, x times a is ax, and x times 5 is 5x. That's the same thing that's happening over here. If I have a times b plus 3 and 5 times b plus 3, now instead of being called x, I have b plus 3 that's in common. So I've got b plus 3 that I'm taking out, and what's left, when I divide b plus 3 out of the first term, is my a. When I divide b plus 3 out of the second term, it's my 5. Okay? This is part of factoring by grouping. So it's by noticing that there's a unit that's in common here, and I'm going to take that unit out, divide that unit out. So it's going to give me 7m plus 2. That's what my GCF is. That's what I'm going to divide out. I'm going to divide that out of the first brick. I've got 3x plus divide 7m plus 2 out of the second brick. I've got 5y. And one more example. We've got in common between these two chunks. We've got 4b minus 9 in common. When I take it out of the first piece, an a squared is left. When I take it out of the second piece, a minus 2 is left. So that would be considered completely factored. All right, in the next video, we're going to start with factoring by grouping.